Okay, everyone, let's go ahead and get started. Good afternoon or good morning, depending on where you're calling in from. My name is Noel, and on behalf of DLT Solutions, I'd like to thank you for attending today's webcast, Going from Paper to Design for Rural Water Utilities. Before we get started, I'd like to go over some logistics. This webcast is being recorded, and to ensure a clear recording, everyone's phone line has been muted. If you have a question, go ahead and type it into the question and answer section on your GoToWebinar platform. This is located on the right side of your screen, and we will answer all the questions at the end of the broadcast. Our speakers today are Darren Dambley and Matt Allred. Darren is a Senior Manager of Government Solutions for Autodesk Government. He is responsible for developing and managing Autodesk business solutions within the federal, state, and local government sectors. Darren brings to Autodesk more than 25 years of experience in the deployment of information systems, including project management, education and training programs, cost and benefit analysis, business process reengineering, methodology development, technical sales, and product and services marketing. Matt moved to Wyoming in 2005 from Southern California, where he has worked in the construction industry, either in construction or in design, his whole life. Matt started working in Guernsey in 2007 as building inspector and acquired the title of town engineer in October of 2008. And with that, Darren, go ahead and take it away.
Thanks, Noel. So folks, today's presentation, we're going to focus on the business end of implementing a computerized engineering record system. So our assumption is that you already have an engineering record system, which may include paper maps or CAD or GIS. So you already have meter or hydrant cards, or you may keep those records on paper or in Excel spreadsheets, for example. So we're going to talk about the whole idea of computerized engineering records. So the big questions I always ask myself when someone is showing me new tools are, number one, why should I change? What can I do that I can't do now? And two, how do I make the change? How difficult is it to learn and use in my current process? So my background is more in the project management of implementing engineering technology. So I'm not the functions and features guy, but I know what it can do for our business. And so that's where Matt and I are going to focus today on the cost and benefits of this technology and how to implement it in your environments. So we're going to discuss it from the business perspective, and then Matt's going to show you from the Town of Guernsey how they've taken this theory and actually are applying it in the real world. So really what we want to go through today then, just wait for the system to catch up here, is how do you maintain your records today? What are the benefits of the computerized engineering records, your implementation components, looking at your scenario, because everyone is slightly different, and then how can you get started? So, what do we do with engineering records today? Well, we do a number of things in your job functions, and I just want to make sure that we use our engineering records in all these different capacities. So it's not just for engineering or water systems. But what are engineering records? They're all of these things. But from a computer, from an IT information technology perspective, we actually break it down into two major categories. So we look at it from a graphics or an attributes perspective. We have a picture, and then we have textual data that we have to keep track of. So that's the way we look at it from a computer perspective. What is the importance of engineering records? Well, they're important for our customer safety, our rate justification, if we're doing any projects, if we're applying for loans from the USDA, for example. There's all sorts of reasons why we have to keep good, clear engineering records. It's our responsibility as maintainers of the system. So some of the questions I like to ask people is, who's using an in-house customer billing system, and who's using an external service to do that? That's one consideration we want to look at. We also want to look at whether or not you're maintaining a lot of your records on paper, or do you have it in an electronic format of some sort. And then we also want to look at your system maps. So I mentioned earlier about dividing the data between graphics and attributes, textual data. Are your system maps being maintained in-house with a CAD or GIS tool? Are you maintaining it in-house with on paper? Or are you using an engineering firm to actually maintain this information for you or maintain these drawings for you? So I come back to the question of why change. I always look at it from a cost-benefit perspective. my kids really, I drive them nuts because they all want cell phones. And I always ask the question, well, why do you need one? What's worth the cost here? How much is it costing me on a monthly basis? More importantly, what's it costing you? Because I make my kids pay for their own cell phones. So, but I always look at it and say, what's the compelling event here? What event is forcing me to change? So let's look at the utility industry and think about what's your compelling events. What's happening right now? First off, we've got infrastructure, aging infrastructure. There's a lot more work that has to be done. We have a lot of people who are retiring. We have new people we're bringing on board, and we have less experienced staff. We also have to attract those new staff because they're coming out of school. They expect things to be computerized. They're looking for these new modern tools to be using. And then we also have the quality of service that we're responsible for. We have new regulatory compliance. Our systems are getting older, therefore we have more leaks and breaks we have to maintain. And our customers' expectations are also going up because as the level of service increases in other industries, they're expecting us to be the same. So let's look at that in a little bit more detail. So doing more work, what does that mean? It means that we're having more as-built backlogs. We've got more data maintained. We have fewer people with the same productivity levels. We have a lot of people who are retiring. So I'd like to ask a question here of the audience. Beside your name on the attendee list, you should have a little symbol for raising your hand. I'd like to ask the question of the group is, who has key personnel that will be retiring within the next 5 years? If you can, see if you can raise your hands on the little symbol there. I wonder if you folks are able to find the symbol beside your name, or you can put up your hand, click with your mouse. Okay, maybe people are having a hard time finding it. That's okay. We'll move on then. And then also, as far as the work challenges are concerned, no single point of truth for network data. One of the things we do face is our data is in different locations. I worked with a telephone company, and they had 32 different locations where they maintained their customer address, various customer billing systems, engineering records, different scale of maps. They had this address located in 32 different places. And so therefore, which one is really the true record? And you probably already have your records that you have more trust in than other records. So what are the benefits of computerized records, of computerized engineering data? Well, these are the categories that generally we break those down into. But I've done cost-benefit studies for a number of utilities over the years, and really what it boils down to is approximately this. To reduce the effort to create your records, there is no real benefit there. You're spending just as much time creating that data as you did in the past. In fact, it might even take you a little bit longer because you're having to add extra intelligence to the data. But where does it save it? It saves it in the maintenance of the records, the analysis of the records, and finding the data afterwards. So one VP of engineering that I worked with had told me that once an engineer draws that hydrant once, that's the last time that hydrant symbol should be placed. My records, my CAD tools should be able to pull up that same symbol over and over again, and regardless of what scale map that it's being shown on, what diagram it's being shown on. So that's where the real savings are. It's not in the initial creation of the records, but it's in the maintenance and the ongoing analysis and retrieval of those records. So when we look at benefits, and we have to look at justifying any purchase of a new tool, we look at it from tangible and intangible benefits. So from a tangible benefit perspective, we look at it in these categories, and what Matt's going to focus in on is the engineering fees. That's where a lot of savings can be established. But also, surprisingly enough, I've worked with some utilities over the years where revenue generation, actually, they've missed meters. They have, because of bad records over time, a meter record may have been lost. Therefore, the meter is actually not being billed. And so, therefore, there's missing fees. But what's interesting in government agencies is intangible benefits sometimes count for just as much as the tangible. And especially if we look at the category of stewardship. Category of stewardship is all about the accountability and transparency of decision making. It's being able to pull up records and show people, hey, this is how we made the decision, this is what we have to go on. And that counts for a lot. So some of the other benefits that we look at is the increased accuracy. Number one, it could be the positional accuracy. Where can you find the valve? Do I have a GPS coordinate that I can walk out into the roadway? If it's covered with snow, I've got dirt that's maybe been put over it. I may have pavement. Someone's paved over a valve cover. So can I find that piece of infrastructure? Also look at accuracy from a timeliness perspective. So am I getting my records updated in a timely fashion so that when I go out next week that the records are actually truthful as far as what's in the field? Or am I looking at a 6-month or a 1-year type of backlog in my record keeping? And then also the completeness. Do I have all of the valves on the map? So there's a lot of different types of accuracy. But the big one also is reducing the redundant and duplicate data. As I mentioned before, the telephone company with 32 different addresses for a customer. That's just ridiculous. We need to trim that down. Now, as far as improving the analysis and reporting capabilities, it's being able to look at the trend of water quality or flow rates over a period of time, being able to create a buffer around a section of pipe and identifying residents that have to be notified, overlaying the zoning and permits data, for example, to look at potential impacts on water quality, being able to show a map of all the hydrants and their pressures, different size mains are going into those hydrants. So that's a lot of the capabilities that we can look at that are valuable to us in managing our water utility network. So what is computerized engineering records? As I mentioned before, it's graphics data on the left-hand side, and then we have attribute or textual data on the right-hand side. And so with computer systems, we have products such as AutoCAD Map, we have ESRI, Bentley, MicroStation. Then on the textual side, there's Oracle, SQL Server, Microsoft Excel, a variety of tools we can use for storing the attribute information. So what are the implementation components? When we look at it, we have two different pieces that we have to put together in the puzzle here. We have a business process, we have existing business processes of data, work functions, and people. And then we have technology enablers. Those are the tools, these databases, data models, software, hardware, communication networks. And whenever we go to implement new tools, we have to look at it as far as we always are constrained by time and money. That never disappears on us. And so we look at the scope of the project. What is the scope? It's what data are we going to impact, what people, and what job functions are we going to impact. So we look at it from that perspective. So we look at it from a solution architecture. So from a solution architecture, we have all these different functions, data products, et cetera, all these things on the left-hand side. So we have to think in advance of where we want the system to be. What do we want it to do for us? And what is feasible from a cost perspective, cost-benefit perspective. So, for example, the Parthenon in Athens, believe it or not, it was designed ahead of time so that the pillars on the corners actually flare out. They don't go up in a perfect straight line. They actually flare out. And the reason for that is so from a visual perspective, when you're looking at it from a distance, they look straight. So someone obviously ahead of time thought about the entire visual solution and thought about what they wanted this to be. And that's what we need to do when we're implementing any computer system. We just don't walk in and plug down any old software and hardware. We have to think in advance what it is you want to achieve from your business perspective. Now, the easiest thing for people to get excited about is they go out and buy the hardware right away. And actually, that's one of the last things we want to do. We do want to look at the major components and where you want to go. So as far as the major technology components for this industry are, number one, CAD, GIS. Number two, having handheld units, Trimble, for example, where we can go out with attribute information and location information. We can also capture information and maintenance information on those devices. Then also web mapping tools, being able to distribute that. And most people, we like to think about internally, even though I say web, that's the mechanism, but it's for internal use. Or we could set up an external type of website for people. And then we also have the text data entry. And so basically those are the technology tools. The data that we're looking at storing, number one, we're always going to have maps and drawings. We're not going to get rid of all the paper drawings that you have, because when you're out in the field and it's a snowstorm or it's bad weather or it's raining, you don't want to be relying on a laptop computer for functioning in that situation. You want to have some hard copy. But as far as the data stores are concerned that we talked about, we do have detailed drawings. So you have detailed construction drawings. You have map data, for example. We have the text attribute information. And then once again, on the right-hand side, we're pushing out reports. We have published paper reports, presentations, et cetera. So let's look at option number one. Say you wanted to do all your mapping in-house within your organization. Basic tools would be, number one, having a CAD or GIS system to help do that mapping, and then having a text data entry, whether it's Microsoft Excel or SQL Server, Oracle, some sort of data attribute maintenance system. And then, once again, we still have all the different data stores that we're responsible for. Those don't go away. Say you wanted to do the in-house mapping and then go to a further level, which is basically having the GPS units, web mapping tools. You could do all of that in-house if you wanted to, if you have the skills and you have the IT resources to do those type of things for you. Another option could be outsourcing components of this. So, for example, you could hire an engineering firm, you could hire a firm such as Comtech to maintain those maps for you. So you send them the paper drawings, the paper maps, and they put it into electronic format for you. The textual data, the attribute data, though, I still believe is very critical that the organization, your own organization, is maintaining that information. So once again, we can split where these things live, but provide you with access to it. And then once again, you can extend it to where you have the handheld units, the GPS units. You're doing the data entry. You also have access to a web mapping tool that could be internal use only, internal access. And you could outsource that data mapping and also the maintenance of that website. So I'm just trying to give you ideas. I'm not saying that this is the must-be answer. It's just ideas of different ways you can implement this technology and these tools. So you need to look at it with what is your scenario. So what are the key issues that you're dealing with? Do you have in-house CAD expertise or GIS expertise? Do you have in-house IT support? The more that you try and bring in-house, then the more overhead you're going to have, but then possibly the lower cost it's going to be in the long run. Outsourcing those different scenarios or just different components could be an option. Could be actually more cost effective, because if you're only doing drawings, really drawings don't change that much. So the maintenance of your drawings is actually a small portion of your time when you're only having to change it once. So doing that work might be very valuable, or might be beneficial for you to outsource that component of it. But that's where you need to look at your scenario and what skills you have in-house. So the next question then is, when do you get started? When is it feasible? So as I mentioned earlier, I'm not a big fan of change just for the sake of changing. So you need to look at it from your perspective and say, do you have key staff that are retiring in the next few years? Do you have a major upgrade that you're trying to get done here? Are you applying for some loans? What about regular compliance? Is someone threatening you with fines or fees? Those are the type of things that I find very motivating to get moving on. So the question is, how do you get started with that? What's the first step that you should do? Well, in all the years I've been in the IT industry, it always comes down about the data. Hardware will change, software will change, operating systems come and go, but the data stays forever. So it's all about the data. That's where you start, and that's where you're going to finish. So with your data, a step that you can do yourself internally is just inventory your data. What do you have? So along the top, I've put down, for example, meter cards, valve cards, 1 to 50 system map. Just create a column for each one of your different documents that you maintain your data on today. Then on the left-hand side, we go through and we talk about the different types of data and what textual or attribute data we maintain about those. So for example, a meter has a meter number, an install date, last inspected, a manufacturer. So you can go through and put an X in every column of where that data shows up. And what you'll start to find out is that the same piece of information is probably recorded in multiple locations. That's the first step you want to go through. Then the other thing you want to do is you want to look around and say, what are the external sources of electronic maps and data that you can get to get you started? There is the customer billing system, obviously. Wyoming has a GIS portal. Many of the states have various GIS portals where you can get electronic data from. Satellite imagery, for example. Engineering contractors that you've worked with in the past might have this data. And then even going to Google Earth and pulling in Google Earth data would be easy to do. So there's a variety of different places. So the second step is, who are the users and consumers? Go through and identify who is actually maintaining this records, and then who is actually using this data that you have to provide it to. So once again, we go through the same process, go through and identify your different data sources that you maintain today, and then go through on the left-hand side and identify those groups. And CRUD is a fun acronym for Create, Read, Update, and Delete. So who has the authority to actually create those records? Who has the ability to read, update, and delete them? Those simple job functions. And what you'll find is most people are doing reading of that information. They're analyzing it. Very few people are actually creating or deleting those records. Some people might update specific fields, such as meter readings, etc., but they're not creating the actual meter itself. So step number 3 then is to go through the functions. What do you do with this data? And an easy way of looking at it is the input, management, analysis, and publish. So we refer to that as IMAP. So it's an easy way of going through and saying, who does all those different job functions? So what do you need to do with that data? What do you have to publish? For example, map books, EPA reports, paper plots, customer newsletters. Where does all that data need to go to? And then, now, those are all the steps that you can do quite easily yourself. But on this step number 4, this is where I do recommend bringing in someone with experience, someone with expertise in the different components of the technology. So you said, this is what I want to do with my system. Now, this is where you actually start defining how are you going to create a computerized engineering record system for you. And so this is where everyone's going to be a little bit, they're going to be similar, but they're going to be a little bit different. And it really boils down to identifying your funding requirements. You have to justify all your expenditures. So you start looking at it and you're saying, okay, well, what's going to be the best way of creating a data model? Is there one I can use already? Do I make some sacrifices or compromises to use this data model so I don't have to create my own? What about the data conversion? That's where you spend a lot of the money actually as far as your biggest investment is getting the data into the system. So are there some inexpensive ways of doing that? What's the pros and cons? So it's going through that thought process, and that's where I highly recommend bring in some external people to help you with this process who have been through it before. So really, in summary, is number 1, look at your current status of your records. 2, think about the benefits. Why is it you should be doing something? What will be the upside for you? And look at your compelling business drivers. What's making you need to change? And then finally, then you can define your solution architecture, because it's your compelling business drivers and it's what benefits you want to achieve will define what your solution architecture should be. Then you can get started with actually implementing a system and getting onto the fun part, which is buying all the hardware, which is the visual part, which is always very rewarding. So with that, I'd like to change things over here to Matt Allred. And Matt works at the Town of Guernsey, and Matt has gone through and implemented a system and has found some great benefits from doing so. So we thought a real-life example would be best for you. So Matt, over to you.
Thank you very much. Good morning, everyone. As Noel stated earlier, I did just get to Guernsey in 2004. Started working for the town here shortly after that in 2007, where I am the building inspector and the town engineer. Every time I hear Darren give that presentation, I go, wow, what can't AutoCAD do? I mean, it's incredible. I know very little, in my opinion, about what AutoCAD can do, all of the different abilities that it has and things that it can create. What I do know is what I can do with it here in the town of Guernsey. That being said, who am I? How did I get here? I have been in construction my entire life. My first job was straightening nails, working for my father when I was just 5. I injured my back on a job in California working as an electrician. And rather than go to culinary school, which I'm sure I would have enjoyed, I went back to school and learned how to use CAD. When I moved to Wyoming and began as a building inspector, I quickly realized that there was a huge opportunity to expand my career from just building inspection into the engineering for the town. By doing that, I started doing the CAD drawings in-house and contracting with other engineering firms when required by the DEQ or the fire marshal. In doing that, I've been able to cut 70% of the engineering fees for the town of Guernsey in just the past year and a half. As I said, MAP can do a lot of things. What do I use it for? Most importantly, I think the town layout. I use it for planning and zoning, water systems mapping, sewer systems mapping, project design. I don't just do the water and sewer system. I design all the projects here in Guernsey as far as my abilities will take me. And when I am as far as I can go, I partner with other engineers. And most importantly, I believe I maintain the records here in-house rather than having to wait on an outside engineer to give me the updated drawing that I'm looking for. Why MAP? MAP saves me a ton of money. Every single job, if I can cut 70 to 100% of the engineering fee, you know, on a typical job, that's going to save me thousands of dollars. I can also do it here in-house when you have to run out in the field, verify a dimension, and get back to somebody else. That all just takes time. The compatibility with other engineering firms and companies is a key feature. There are a lot of engineering companies that use other products, as Darren alluded to earlier, but even all of those have a copy of CAD in-house. There's not an engineer or architect that I have met that doesn't have CAD. Maintaining the control of your own data. When you find something in the field that is different than is on the drawing that you have, that paper document, maybe you never got an as-built drawing, you can go right to your drawing, modify your drawing, and update and maintain the control of that data in-house. Most importantly, how to get started, right? Projects can be overwhelming, especially when you're walking into something new that hasn't been done before and you're just creating. When I got to Guernsey, I was handed this map. It's a hand-drawn zoning map of the town, not to scale, not any particular order, no really rhyme or reason. They handed me this and they said, here you go. From there, I quickly realized that I needed to convert that into a town plot that was to scale so that I could actually start engineering some jobs here in town. You have to start with the basics. You take the overall job and you break it down into the smallest pieces. You build the image of your town to scale so that everything, all of the data, the empirical data that you're going to add to that drawing later is all where it needs to go. By doing that, you start with just a block, just 4 lines in a square, maybe a polyline in a square. From there, you add more blocks. Myself, I had to go out into the town here with a measuring wheel and measure the width of the streets and measure the width of the blocks. All of that is time saving and money saving because the engineering firm isn't having to send its guys out here to measure and draw sketches of the blocks and the streets in the town of Guernsey so that they can go back and implement those and put them into a drawing. After you've drawn one block, you draw the next block. Multiple blocks make sections or zones. In this slide, the different colors are referring to different zoning. Then you start adding your attribute data. Again, it's a fancy name for text, but it's important. Every bit of information that you put into your drawing is going to be referenced over and over and over again. By drawing it one time, you save yourself the time every time you open that drawing. Every time you refer to that drawing, you have just saved a ton of money from an engineering firm. After you've added some streets, you add the street numbers. Addresses. Everybody's house is referring to an address where that location is on a specific block. Then you add lot numbers. The next thing you know, you're really building your town in CAD in a reference file that can be accessed at the drop of a hat. The next thing you know, you've added all of your blocks, your street, your names. You have your town plot. Now this file, this document, is the basis of every drawing that you're going to do in your town from this point forward. You have encapsulated your town limits. Everything that you do is going to take place in this drawing in your town. Some municipalities are quite a bit larger. Some are quite a bit smaller. Maybe your town won't fit at a 1 inch equals 200 foot, 500 foot. Sometimes you have to go small, but it's all right there. Everything you do is going to reference this one drawing. You, again, have just saved your town thousands of dollars in engineering fees. If it took 120 hours to do your town plot in actual physical work, that adds up to a lot of money when you're talking about $160 an hour for a principal engineer, $120 an hour for a drafter. Who knows what the prices are going to be, but they are high. Now you take your town plot that you've just created and you build. You work on that town plot to draft a project. Like I say, and I'm going to say it over and over and over, every drawing that you do is going to be placed on that town plot. This is a project that I've drafted here in Guernsey for a sewer line. We have some very old sewer line projects, some original sewer lines that were put in the 1940s. That's old clay pipe. Some of it's breaking, a lot of it's leaking. We have some urgent need for sewer repair here. By using CAD, I was able to design this project and take it to the State Land Investment Board. The complete project is fairly expensive. It's close to $1 million. I can't get the funding for a $1 million sewer project in the town of Guernsey. We only have a population of 1,175. So when the State Land Investment Board said, you know, that's a little bit much, can you break that down? Well, I said, indeed, I can. I came back to my town plot, copied it, saved as, and broke the project down into 3 phases that were attainable financially and labor-wise. So phase 1 took care of a situation where the National Guard wants to build a building, and they were going to put it over an existing sewer line. So we did that as project phase 1. Phase 2 was removing the line, the sewer line that was put in the 40s, and sometime later in the 70s, much before I got here as the building inspector, the town was allowed to build a school over the sewer line, which is outside of the code standards. So at that point, I decided that would be the next important part of this project, is getting that sewer line from out under the school. Thirdly, we have just put in a new swimming pool, and the sewer line is running approximately 6 feet from the new swimming pool. So rerouting the sewer lines around that block was necessary. Now this is 3 different jobs that all add up to the Nebraska Avenue Sewer Line Improvement Project. Each time and each phase of this project, doing it in-house, contracting out with a certified PE to stamp the project afterwards, was only $3,500. So on a project that's $1 million, that is a very substantial saving. Design documents cost 10% of the construction estimate. That's just to get the drawings into the bid phase of the project. Construction documents can cost under 15%. On a $250,000 job, that's $62,500 in design fees. That is on one job. AutoCAD gives you the ability to do more work and save on design fees. What I mean by that is to say that the money that you saved your town by doing the design work will allow you to turn around and put that money right back into the ground in doing more projects. This sewer sleeve project bid out at $162,093. I partnered with an engineering group to get the DEQ permit for a cost of $3,500. On this project alone, I saved the town $37,023.25. Every time that you do a job, that you do a drawing, it's going to be based on that town plot. If you look at this drawing, you see a couple drawings, section drawings of manholes, where the manhole goes. You'll see the dotted lines where the sewer line sleeving is going to go, but what else do you see there? The background is your town plot. That was already done. So the money that I saved the first time by drawing the town plot, I saved it again by doing this bid. Every time a municipality puts a project out to bid, that bid gets awarded to the low bidder. The low bidder is not always the same, and in most cases is rarely the same engineering group that designed the first phase of the project. So they have to come out and do your town plot. They have to measure the streets, look at the blocks. Where is the project going? You pay for that over and over and over. That's why I say you save over and over and over. Every alteration to a job means a new set of plans. This job came in under bid, actually, and I was able to go right back to the drafting table, to my desk, to AutoCAD, and design areas that were in the most need of this sleeving project. 3 different times. That's 3 different delays in construction. 3 different times that I would have had to wait for an engineer. 2 weeks, 3 weeks, more, it's hard to say. Sometimes they're right on it. Sometimes they're very busy. Why not cut that time in half? Why not cut that time out altogether? Don't let a delay send your workers away. Every time on this project, this is the sewer sleeving material that's going in off of a roll, going into the sewer lines, which are underground. This manhole is about 9 or 10 feet deep. These are specialty items that take time to get. By being able to do a change order in-house on a project and not have to wait for an engineer to send a person out, do the examination, you can keep the project rolling. You can avoid costly delays. The change order that I did for this project took 2 days to get through the design and the DEQ approval. It's that simple. One map for all your utilities. Switching gears a little bit here. Design is one thing that we do. Mapping is another. By mapping the utility system, you start with the same town plot. You define the coordinate system so that you put your town on its specific space on the globe where you actually are. Then you add the lines to represent the water system. You draw polylines. You add the lines to represent the sewer system. Again, I'm only using a few commands here in AutoCAD. AutoCAD will do so much more, but we're just talking about focusing on a specific job type. After you've added the lines, then you add the text, the attribute data, to define the line size, to define the locations, to show specifically where things are. Insert blocks to show valve and meter location, show the location of all the fire hydrants, and once you place all of these objects, that's, again, the last time that you're going to have to do that. Not to say that when something happens in the field and the town, you have to open up a hole in the street to get to a valve, maybe a valve breaks or something, and you find something different. At that point, you say, I'm going right back to my map. I'm going to change the original objects that were in there. I'm going to update those files, and now I've just maintained my data. I didn't have to draw on a map with some red pencil or ink and send it off to the engineering firm and wait for that to come back. If it comes back, you do it right then, right there. You maintain your own data, all by starting with the town plot. You add the lines and text. That's all. This is a map showing my water system. Not rocket science. It's lines and text. You build your map with multiple layers and GIS. Layers are the key. Water on one layer, sewer on another layer, residential blocks on one layer, commercial blocks on another layer. Everything has its own layer and control. By coordinating your map with GIS for your specific location, you can import other file types from a portal at the Wyoming University. You can query in other drawings. You can build and build and build everything on one map. You have complete control over that map. Record keeping. This is a huge one. By controlling and keeping everything on one map, you can avoid having to go up into an attic. I don't know how many of you have ever had to go search out a specific set of drawings for the sewer system or the storm drain system, but how much time do you spend digging through a pile of prints to find that one, for that one valve isolation on Main Street, or through those boxes that are on the right there to look for that hydrant exercise schedule? With MAP and AutoCAD, everything can be kept in that drawing file. Every time that you exercise a valve, you can add that data to that file. Additional capabilities. I mean, like I said, I know how to do what I'm doing here in Guernsey. What I know for sure is the increase of analysis of data, a 7-to-1 increase. I can find things at the drop of a hat. When somebody from our maintenance group comes in here and says, Matt, where's this valve on Chugwater Street? I can go right to it. I can show them where it's at. Don't have to even open up that paper document. Not that you don't need the paper document, like Darren referred to earlier. You do, because you can't take your computer. I can't take my desk out into the field. But I can certainly print out a window of that plan. Keep all the valve, hydrant, meter reports safe and in one place. Use the data filters to create multiple types of reports. Again, as Darren talked about, you can create a report to show the address of one house if you want to turn the water off, where every valve is that you need to close. You create GIS data for every valve, hydrant, meter, manhole, water well, every other item you can think of. All of that data can go into that one drawing. Every job you do is a record. This is a job that we had to do out at our airport. We have a small municipal airport here in Guernsey, and the state said that we needed to change out the fuel lines that are underground. We have steel, non-cathodically protected fuel lines that run from the airport fuel tanks to the dispensers. Instead of having to go out and hire an engineer, I said, well, let me see how far I can get on this project. This project, it turns out that the fire marshal was willing to look at my drawings. So was the DEQ. In this particular project, I didn't even have to partner with an engineer. This job is going in at about $125,000. I saved at least $25,000, again, on this job. Every record has to be stored. Every job is a record. All in one place. You can back up your system. I keep mine actually on the server and a little flash drive. I have a flash drive that I keep every drawing for the town on, and I keep it with me just in case something happens here. Not to say, and knock wood, that it will, but just in case, it's very easy to back up all of your documents. Everything you need to do is right at your fingertips in CAD. That is my mantra. That is my belief. Everything that I do for this town starts with CAD, finishes with CAD. Working with AutoCAD Map 3D. In summary, I would say work smart, save money, avoid delays, create and maintain records as you go. Whenever you find those out in the field, you come right back, make the changes, make the save, create and save as you go. Find the right records when you need them. Every time you open that drawing, you're going to find those records. That is the conclusion of my webinar. I would like to thank everyone, and if you have any questions, please feel free to forward those on. Thank you very much.
Matt and Darren, thank you guys very much. That was a terrific demonstration. You guys gave a lot of great tips on how you could use CAD to save some money, and that's what it's all about. For the attendees on the line, if you guys have questions, go ahead and type them into the question and answer dashboard on your GoToWebinar control panel, and we will go ahead and get those answered for you. Let's see, Matt, I have one that came in for you. Can you talk a little bit about the flood trace technology? I think you touched on this a little bit. Can you maybe expand on just how easy it is to figure out which valves to close and isolate a system break?
That is yeah, certainly. I can talk, in fact, just a little on that. That is one of the reports that you can filter out while using MAP. Again, the key there is to getting everything installed in the correct place with GIS coordinate systems, and then in the Files menu, in the Tools, you can choose to filter that project out. What it does is it gives you a flood plain, what they would call a flood plain. It'll put a hatch around a localized area. Personally, that is one of the tasks that I am still learning. Every time, I've only done it twice. Each time I actually have to go to my owner's manual, AutoCAD Map 3D, a practical guide. Go to the chapter and go through the steps. But what I would suggest is actually doing that. What I'm working on currently is actually getting an image, a cadastral image, from Platte County, the county assessor's office, that actually has all of the registered plats for the town of Guernsey with the owner information, contact information, their phone number, address, square footage of the lot, and so on. That will, at that point, generate an Excel spreadsheet that gives you all the phone numbers and addresses of people to call. As far as the actual steps of going through that, I think probably some of the people at Comtech would be better equipped to give the specifics on how to actually provide that report.
Okay. All right, Matt. Thanks very much. Let's see. Another question, and I'll toss this up to either Darren or Matt. Can you explain the difference between AutoCAD and MAP?
This is Darren. I think I can answer that one. So basically, AutoCAD is the Autodesk baseline CAD product. We have another product, an extension called AutoCAD Map. So it gives you extra functionality for mapping and utility infrastructure data specifically. So it is a separate product, and it is much more rich in functionality for this type of functionality and application.
Okay, great. So we had another question come in. And Matt, it looks like this one is directed towards you. People want to know, how long did it create your town map?
The town map, it took me probably 3 weeks. Unfortunately, and I think this is probably another situation that other municipalities will deal with, the town of Guernsey got to its size over a long period of years in 3 different additions to the town. The first and original addition to the town was on the west side of town. I'm sorry, the east side of town. Back in those days, it wasn't really a practice to have surveyor stakes marked. So the town of Guernsey was actually plotted out using a big red rock that was in one of the parks in town. Somebody just decided that was a big enough rock, it wasn't going to go anywhere, and they just started measuring off of there. When I started making my plot of the town, I certainly, every time you expand a town, you annex land. Those are plotted in and put into the major map. Unfortunately, every time that happened, there wasn't one map that was kept up to date. So when I went through and actually went out and measured everything with a wheel and drew it in place, not all the streets lined up. At that point, it got a little more complicated. I had to do some more research. But for the town, I think about 3 weeks of pretty consistent work is what it took me to plot out the town of Guernsey.
All right, thanks very much for touching on that. Looks like we're all out of questions. I'd like to thank both of our presenters. That was a lot of terrific information. For all the attendees on the line or for those watching the archived webcast, if you have any additional questions, feel free to contact us at the phone number provided, 888-447-2223, or send us an email at autodesk-solutions@dlt.com. That wraps up our webcast for today. Thank you, everyone, for attending.